All right, today we're going to work on solving absolute value equations and inequalities. And we're just going to have to learn a couple extra things with absolute values. The biggest one is that every problem is really two problems. So we're going to look at it as two problems, or the book is going to say two cases. And so this first paragraph up here is just really a fancy way of reminding you that absolute value is always, always positive. If you have the absolute value of 6, then the answer is 6. If you have the absolute value of negative 6, then the answer is still positive 6. And then these steps here, this is how we're going to solve problems. We're going to get not the x by itself, but the absolute value expression. Get the absolute value bars part by itself. Then we're going to teach you how to write two cases. You're going to turn every problem, once you have the absolute value bars by itself, into two problems, solve each one, and then you have to check your answers here. We're going to have these things called extraneous solutions, and so you have to check your answers. And so let's walk through those steps again. This is my problem. The absolute value of the x plus 4 plus 7 equals 19. So I minus 7 to both sides. I have to get the absolute value part by itself. And then I turn it into two cases. Why two cases? If this is positive 12, then the answer is 12. If this is negative 12, then the answer is 12. And so both would work, positive and negative. So one positive, one negative. The absolute value bars go away. One side's positive on the right side. The other side is negative, the right side. Minus 4 to both sides, x equals 8. Minus 4 to both sides, x equals negative 16. Again, I probably should be plugging it back in to check. And so I'll plug it back into the original. 8 plus 4 plus 7, which is 12, plus 7, which is 19. So that checks out. I want it to be 19. All right, over here, negative 16. My brain's thinking the answer. Negative 16 plus 4 plus 7 is the absolute value of negative 12 plus 7. Well, that's just 19. The absolute value of negative 12 is positive 12, so it checks out. I haven't really gone over extraneous yet, so I knew they were going to work. But we're going to have to get to the habit of plugging them back in and checking to see if they work. And so the book's first example really isn't any harder. It just is longer. We're going to add 9 to both sides. We have 2 times in parentheses, or in absolute value, the quantity 5x plus 1 equals 4x plus 26. I'm going to get rid of the 2 by dividing 2 to both sides. And so I get the absolute value of 5x plus 1 equals 2x plus 13. So case 1 is just leave everything positive, get rid of the absolute value bars. Case 2 is get rid of the absolute value bars, but make everything on the right side negative. So I put this lead negative here. Over here, I had minus 2x to both sides. And minus 1 to both sides. I divide by 3 on both sides. On the right side, the first thing I have to do is deal with that negative that's on the outside. It makes everything on the inside the opposite. Add 2x to both sides. Minus 1 to both sides. Divide by 7 to both sides. So you have two answers. You plug it back in. Up here, 4 times 5 is 20, plus 1 is 21, times 2 is 42, minus 9 is 33. So that side's 33. 4 goes here. 4 times 4 is 16. Plus 17 is 33. So 33 equals 33. That checks out. So this is one answer. Do the same thing with negative 2. 5 times negative 2 is negative 10. Plus 1 is negative 9. The absolute value of negative 9 is positive 9. 2 times 9 is 18. Minus 9 is 9. So this side is 9. 4 times negative 2 is negative 8. Plus 17 is 9. So 9 equals 9. That worked out. So this is an answer. So I'm going to change this example. We're going to use an easier one. But let's talk about this word here, extraneous. Right? Extraneous. Right? That means that the answer, you did all the work right. There's nothing wrong with your work. The answer just doesn't fit back into our original equation. It's an extra answer that's not needed for our case. Right? It's not going to happen a ton to us in Algebra 2 class. It's going to happen some more times other than just absolute values. But we're going to need to remember that it's a thing here during absolute values. So we're going to use the example, the absolute value of x plus 1 equals 2x minus 2. It makes it a little bit easier for us because we already have the absolute value by itself. And so I go right to case 1. And case 2. Again, on case 2, I just make everything the opposite. Right? Or I could think of it still as x plus 1. I could think of it still as x plus 1 equals negative the quantity 2x minus 2. And then I distribute that negative to everything, makes it negative 2x, or everything becomes the opposite, negative 2x plus 2. Here I minus on the left. When I say here, I'm talking about over here on the red. Sorry, case 1. Minus x to both sides. I get x minus 2 equals 1. Add 2 over to both sides. I get x equals 3. On the right side, I have to add 2x over. Move the smaller x, negative 2 is smaller, so I add 2x over. So I get 3x plus 1 equals 2. Now I want to minus the 1 over, so I get 3x equals 1. Divide by 3 on both sides. I get x equals 1/3. Now let's see what happens when we plug it back in. Right? And so absolute value 3 plus 1 equals 2 times 3 minus 2. Is that a true statement? Well, 3 plus 1 is 4, so the absolute value of 4 is just 4. 2 times 3 is 6, minus 2 is 4. And so that's a true statement. So this is an answer that works. Over here, let's plug it back in. Absolute value, 1/3 plus 1. I probably need to write that smaller. The absolute value, plug in 1/3 plus 1 equals 2. Plug in 1/3 minus 2. 1/3 plus 1 is 1 1/3, or 1.3 repeating, positive. 2 times 1/3 is 2/3. And so 2/3 minus 2 ends up being negative 1.3 repeating. Well, are those the same? Well, they're kind of the same. They're both 1.3 repeating. But one's negative and one's positive, which means they're not the same. And so this answer over here ends up being extraneous. So the only answer for real is x equals 3. If it asks you to list the extraneous, you'd say that x equals 1/3 is an extraneous solution. The empty set is a trick, and if you realize it's coming, it saves you time. If you don't, then it wastes a bunch of time. And so you really, really want to understand this one because you want to save yourself time. Same first step. I have to get the absolute value by itself. So I'm minus 10 to both sides. Now, if you go back, we've had negative answers. -2 was an answer, right down here. So I have no problem with negative answers. When I plug them in, plug -2 back in, I got +9. So I had no problem with that fact that the answer was -2. Over here, this is before we've done any work. Can the inside of an absolute value ever be a negative? No. And so no solution, or it's an empty set. If you did all your work, you would do all your work out. Case 1, case 2, you get down, you plug them both back in. Neither one works out. Why is that happening? What's going on? You didn't realize it was an empty set. So if you can catch this early, then it makes your life a lot easier. Once you have the absolute value by itself, it cannot be a negative. Now, you can probably solve this scenario without using absolute value. I'm going to show it to you using absolute value. The NFL regulates the inflation or air pressure of footballs used during games. It requires that footballs have an air pressure of 13 pounds per square inch, otherwise known as PSI, plus or minus 0.5 PSI. What is the greatest and least acceptable air pressure of a regulation NFL football? So we want the pressure of the football, all right, whatever the pressure is, minus the 13 that was supposed to be. We want that to be plus or minus, so absolute value, because it doesn't matter if it's up or above or below, to be around 0.5. It can be smaller than 0.5, it just can't be bigger than 0.5. Right. And so I would do my case 1, case 2, P minus 13 equals 0.5. Right. And P minus 13, P minus 13 equals negative 0.5. Both cases, I want to add 13 to both sides. Here I get 13.5. Over here I get 12.5. Add 13 minus 0.5 is positive 12.5. And so the least it could be is 12.5. The greatest it could be is 13.5. If I wanted to graph that real fast, it would just go 12.5 to 13.5, and I can have anything in between the two of them would be okay. Now, this looks like a big, complicated slide, but really the slide, if we really break it down, is really easy and very important. Case 1 and case 2, just like before when it was equals. Case 1, everything stayed the same except for the absolute value bars are gone. Same as equals, nothing changed. Case 2, just like equals, the right side became negative. So all this is really saying is when you make case 2, the right side being negative, you have to flip Pac-Man. You have to flip the sign. So when you make the case 2, when you make C negative, you have to flip the sign. Very important. Please put that in your notes. When you do case 2, when you make the right side negative, you have to flip Pac-Man. At the bottom, it's just saying that that's still true if it is less than or equal to or greater than or equal to. And so let's look at this example. Again, I have to get the absolute value by itself, so I add 5 to both sides. I get the absolute value for x minus 8. I added 6, so I get 16 over here. So it's less than 16. Case 1, everything stays the same. no absolute value bars. Case 2, no absolute value bars, but the 16 becomes negative. And when the 16 becomes negative, I must flip the sign. You must do that for case 2. All right, let's solve them now. Add 8 to both sides. Divide by 4 on both sides. On the right side or green side, add 8 to both sides. Divide by 4 on both sides. And then it says graph the solution set. So let's graph the solution set. So I know my number line has to go from -2, 1, 0, 1, 2, 3, 4, 5, 6, all the way to 6. Like I know those are my answers, so the number line has to include those. Open or closed circles. Well, they're both don't have or equal to, just greater than or less than signs, no or equal to. And so they're both open circles. So over here at 6, open circle. And then over here at -2, open circle. At 6, the variable's on the left, so it's going to go the direction the arrow is pointing. So I know it's going to go to this direction. For the -2, the variable's on the left, so it's going to go the way the arrow is pointing. And so I know it's going to go this direction. If they're going towards each other, then all you have to do is draw the connection between the 2 points. Sometimes they'll go opposite of each other, so you got to have arrows where they go opposite directions. All right, but if they're going towards each other, we're just going to connect. Give the homework a try. That's page 89, 1 through 15 odd.